Hello and welcome back. In today's video, we're going to talk about drone data versus traditional survey data. How drone data compares to traditional survey methods for infrastructure documentation. Infrastructure data can be collected using multiple methods, with drone-based data capture and traditional survey techniques being two of the most common. Drone data refers to imagery and spatial information collected from unmanned aircraft systems using aerial sensors. Traditional survey data typically involves ground-based instruments, manual measurements, and established surveying procedures. Both methods serve important roles in infrastructure documentation, but they do differ significantly in how data is captured, processed, and applied. Now, why does accurate road and pavement mapping matters to agencies? Roadways represent one of the most valuable and visible public infrastructure assets. Accurate road maps support maintenance prioritization, safety planning, budgeting, and capital improvement programs. Without reliable spatial data, agencies risk misaligning funds or overlooking emergent issues. Drone mapping offers agencies a way to improve visibility across road networks while managing costs and asset constraints. Now, there are different types of road and pavement assets documentation that goes along with mapping. Road and pavement infrastructure includes more than just surface material. Mapped assets may include lane geometry, shoulders, mapping, signage, curb, drainage features, and right-of-way context. Understanding these elements spatially allows agencies to assess how road components function together. Drone mapping supports this holistic view by capturing continuous corridor-level data. Let's move on to how drone mapping is conducted for roads, the step-by-step process. Drone road mapping begins with corridor planning and airspace review. Flights are designed to capture consistent coverage along road alignment. Imagery is collected and processed to create spatial reference outputs, and these outputs are reviewed and prepared for integration into the GIS and asset systems. The structured process ensures that mapping data is both usable and defensible. And when this data is collected, it has to be able to integrate with the GIS and planning systems. Road mapping data is used across multiple public works systems. GIS platforms store spatial road features and attributes. Asset management systems reinforce mapped data to support maintenance and conditions tracking. Mapping platforms provide visual context for internal review and external communication. Alignment across these systems enhances the value of road mapping effectively. Now, there are some common challenges and risks in road and pavement mapping. Road mapping projects face challenges when coverage is inconsistent or data lacks spatial alignment. Incomplete documentation may omit critical assets or contexts. If data is not standardized, it can be difficult to compare conditions over time. These challenges reduce confidence in road condition assessments and planning decisions. Here at Greece Aerial Technologies, road mapping is approached as an infrastructure documentation task, not a flight exercise. We focus on consistent coverage, spatial accuracy, and system compatibility. Our outputs are structured to integrate with the GIS, asset management, and planning environments. By emphasizing usability and documentation quality, GATT supports road mapping data that agencies can rely on for long-term decision-making.